Right, so we're live from the Warfield Brewing Company in Smithfield, Virginia. Welcome, ladies and gentlemen, to the March 2020 HAMS, the Hop and Malt Society of Smithfield March meeting, and tonight's educational segment that I know y'all been waiting for. You've been waiting up since 2 or 3 o'clock this morning wanting to talk about water chemistry. I know Dave was like just salivating back there. It's like, water chemistry, all right, this is really cool. So in 15 minutes or less, I'm going to tell you what I've tried to jam into my brain over the last 2 or 3 or 4 weeks now of understanding water chemistry, and we're going to build off of what we talked about back 2 months ago, I think, in residual alkalinity. Another riveting session that actually it was right before Christmas, so many folks weren't here. So let's talk about a little bit about water chemistry. So why does that matter? Well, 90-odd% of beer is water. If you drink Bud Light, it's probably about 99% water. So it's really important. So what the water is made of makes a lot of difference in not only the flavor, but the aroma of the beer. And so at the end of this block of instruction, hopefully you'll understand how some of the various salts in the water make a difference in how the beer tastes and how it smells. But also we have a practical exercise. So what I did was I added some of those salts to the same beer. It was an IPA that I made with just Smithfield tap water that is lacking a whole lot of things, as I'm going to point out to you. I added some of those things so you'll be able to taste how when you add, for example, calcium to a beer that doesn't have any calcium at Brew, how it changes in this case, the body of the beer. So we'll set that up. So before I get to that, let me orient you to my map here. So starting at the top, here's a little discussion about pH, and I'll get to that a little bit. Then residual alkalinity, another riveting topic. Then this is basically a matrix of the minerals or salts that are in a couple of different Smithfield, Los Angeles, and then 2 different sort of recipe waters out of Beersmith that most folks have. And then at the bottom, unfortunately, it's kind of hard to see. I know you guys are way back there, but you'll see the film. You know, the film at 9 talks about the impact of these various salts in the beer. So let's start at the top here. So kind of back to where we were a few months ago, water and the mash. So in order for the enzymes to convert the starches to sugars so that the yeast can consume those sugars, you need to have a mash pH that's about 5.2 to 5.6. Well, our local water, and most water in this side of the country, our local water is 7.5 to 8.4. I've tested a whole bunch of it around here. It depends upon the time of the year, but it's somewhere in there. So how do you get from 8.5, let's call it 8, down into the 5s to get to the proper mash pH? Well, part of it is the grain that you use has some acidity to it. The darker the grain, the more acidic it is. You can add some acid to it, and that'll bring the pH back. But what makes it much harder is the minerals that are in the water itself, and that's residual alkalinity comes in there. So to do a proper IPA by the guys, the Brew and Water table, I'm pointing at Jeff because we both were fooling around one day on that spreadsheet, they call for a plus 30 to minus 30 residual alkalinity. Well, our residual alkalinity here in Smithfield, using our water, starts at about 170 and goes to like 360. If you use the Chuckamuck water, remember Adam and Mike Smith were having a real hard time with the water. They're Chuckamucks. Well, it's because there's so many bicarbonates in it, you can't add enough malt, you can't add enough acid to get it to IPA level, which should be somewhere in here, plus 30 to minus 30. It's like, I think it was 320 was Chuckamucks. Mine's at like 240, right? So it's off the scale. So you can brew, as many folks have found, brewing porters and stouts works reasonably well because that'll move the needle back to the left. Thank you very much. And but it really doesn't do the job. So you're still brewing, you're mashing with a high pH, which then pulls the tannins out of the husks. I know this sounds kind of geeky, but you end up with a beer that has some astringency, and the beer I brought tonight has a little bit of that, which continues to frustrate me. And so thus my quest to figure out how to fix mash pH, but also the body and the aroma of the beer. All right, so part of this chart right here, I ran it, my yellow marker was gone. So the idea is that the higher the residual alkalinity, the darker the beer you want. That's the reason why they brew stouts in Dublin. They have a very high residual alkalinity. They brew, brown beers in Burton in England, et cetera, because that matches the water. And Pilsen has like no residual alkalinity. It's almost negative. So that's where you get a Pilsen beer, right? So that was from the last class. All right, now let's get down here. I know these numbers are hard to see, but I'll explain as I go along. So on the left-hand side, Smithfield, Los Angeles. This is the dry pale ale / IPA set of water numbers that come out of Beersmith and Brew and Water. And then a New England IPA. And you'd think they'd be the same, but they're actually opposite, and that's kind of interesting to me. So across the top, calcium, for those who were asleep during high school chemistry, calcium, magnesium, sodium, sulfate, chloride, and then bicarbonates, and you can represent those in a couple different ways. Boring, right? All right, so here's where it starts to matter, right? So Smithfield water, let's talk about it here. So back to residual alkalinity. Residual alkalinity, what you end up with is this battle between calcium and bicarbonates, right? So you got positive ions on one side, negative ions on the other side. And if they kind of balance out, then you end up somewhere around 0 right here. Well, here's the Smithfield water. On the positive ion side, calcium and magnesium were like nothing, right? It measured 0 at my house, but if you got a sensitive enough test kit, it'll come up with 5, which is what Adam had on his, what he sent off and paid $40 for. And then on the bicarbonates, they're 240. So that's like way above everything else. So 5 and 0 don't work well against 240, right? So the competition goes way to the alkalinity side. So when you try to do something with a water that's that alkaline, again, that's how you end up in this area. Right, so now let's talk Los Angeles. So now look at the difference here. We're 5 and 0 just in these first two. They're 63 and 22. So much, much different. But, so that's, people call it hard water. We think we have hard water here. It's actually not. It's very soft. Los Angeles has very hard water, 63-22. Look over here on the other side, no bicarbonates, it's 0. So they have the opposite problem. So two different coasts, two different kinds of water, and you got to make adjustments. You can't brew the same beer with both of the same water and get the same results. So that's part of the point of this is that whether you're doing an extract or anything else, is that that alkalinity makes a difference in how the beer comes out and how well the starches will convert. All right, so now down to because again we're focused on IPAs, so now down to the dry pale ale. So now look at the difference here. For calcium, this was the recipe, which is actually higher than what they say. 150 is as high as they say recommend. So 190 versus 5. Well, that makes a difference, right, in how you brew your beer. Not only in how the yeast produces, but just in the mouthfeel, which you'll see later on. So 190, 15 on the magnesium, which helps the aroma, and then you see the numbers going across. So just look at, for example, with sodium, the salt, this is 30, which is actually pretty high. We're at 138. I mean, that's pretty salty water. Again, imagine why, from where we are. But just look at the difference in how the beer would come out. So then get to the sulfates. 329 for sulfate, we have 0. And 165 for chloride, and we have 70, right? So that's a big difference. And the chloride and the sulfate, especially with an IPA or a beer you want to make hoppy, makes a difference, which I'm going to talk about in just a second. And then 15 on the HCO3. So 15 versus 190, you can see where these numbers here, if they're in a dogfight, that's going to pull the residual alkalinity back to the left, where ours goes all the way to the other way. So there's that water would be somewhere over in here. You know, it'd be easy. You wouldn't have to add any acid. All right, so you'd think a New England IPA, which tends to be very cloudy, you know, very hoppy, et cetera, would be the same. It's actually in the key categories. Lots of calcium, lots of magnesium, salt's about the same. But look, they're opposite. So the chloride to sulfate ratio, or sulfate to chloride, in this case is 2 to 1. It's 1 to 2 in the other way, right? So we got 329 to 165 in the American IPA. I know it sounds kind of geeky here, but 75 to 175. So it's actually the opposite. So the higher the sulfate level, the more hop bitterness you get out of the beer. The higher the chloride level, the more maltiness you get. But the combination of the two and the high magnesium actually brings both of them out pretty well in the New England IPA. Again, as long as I'm not seeing the backs of people's eyes at this point, look like a great white shark rolling back. So the point is that when you lay these numbers up against each other, I know it seems really geeky, but it really makes a difference in how the beer tastes. Because you can see the dramatic difference. Look at our water, look at the water they recommend, and when you start adding, go to a Brew and Water spreadsheet, you got to add like 10 grams of like gypsum to get to some of this stuff. It's not insignificant in some cases to build the water to go to that, and it really makes a difference. What I tried to do tonight was I brought, again, an IPA that I have, And I added some, and again, I came screaming to the house about 10 minutes to 7, so I didn't have a whole lot of time to make sure that I got, quantities that you could actually taste, but I think you can, because it doesn't really take a whole lot of calcium to change the mouthfeel of the beer. And so the last bit that I want to talk to down here at the bottom is what each one of those things do to the beer. So, and this is the chloride to sulfate ratio, so when you get up here closer, you can see where I've got arrows pointing one way or the other. When you have a higher chloride to sulfate ratio, or sulfate to chloride ratio, you'll get a hoppier beer. That's when it's the other way around, you get a maltier beer. So if you wonder why, and this is again frustration, I've been adding that crap out of hops, trying to dry hop, doing everything, and I still end up with a pretty malty beer, which works good if you're doing a wee heavy, but if you're doing an IPA, they tend to be too hoppy or too malty. Not too, but I mean you can't get too malty, but by style, you want to have something, you want those hops to really come out and hit you. But the water, because of this right here, doesn't let you do that. Now the next one, so calcium versus bicarbonates. By adding the calcium in there, it really adds body to the beer. Surprisingly, you just add a little bit of calcium to a glass of beer, and again, calcium chloride or calcium sulfate, and it really changes the character of the beer. Surprisingly, little amounts. Without it, you end up with almost a kind of a thin beer that can be a little bit astringent because the hops really kind of cut you on the back end. Again, down to the magnesium. Magnesium, by adding that, really brings out the aroma of the hops. And thus the reason why you see really high magnesium numbers here. We have 0 in Smithfield, right? And then lastly, the sodium, salty. Some beers like a Goza actually require you to add salt to them. But we have, compared to everybody else, so you look at the sodium, we're at least twice what anybody else's water is. So, Jeff and I were on the phone here a while back. I was getting ready to do a New England IPA, talking back and forth. And it's like, okay, if you go 50-50 dilution, with distilled water, you still end up with too damn much salt to make the beer work. And so it's like, okay, take the water that you drew from your tap. It's not bad to drink. It's just not good to brew it. Take the water you brew, put it in the mash tun, or put it in the hot liquor tank, and then dump it in your garden and put distilled water in there and start all over again. Because that's about, in terms, if you're brewing an IPA, I mean, you could do other things with it, but if you're brewing an IPA, you can see how mismatched these numbers are with what, especially these two lines right here, with what, folks who are really making really good IPAs do. So it's a stark difference. The water you brew with makes a lot of difference in the beer that comes out on the other end, both in flavor and aroma. And so, not to bore you too much with all this stuff, but water chemistry matters because 90-odd% of the beer is water. And if you do the water right, you'll have great beer. So, any questions on this? The question is about astringency, and because inadvertently, I got my pH meter went belly up, and so I must have brewed at too high or mashed at too high of a pH and got some astringency. And you tasted a little bit on this beer right here. When I added calcium to it, it seemed to kind of mitigate some of that. It didn't particularly go away, but it surprisingly just changed the character of the beer where I didn't really notice the astringency as much. Dave?
After kegging?
Yeah, I just all I was doing was just because literally I was playing around with this, and I just kept adding a little bit of samples to a glass of beer. I'm standing around my garage with little small glasses and keep hammering them back and keep adding stuff to it, and eventually you get hammered enough you don't taste the problem anymore, or you think that whatever you're adding actually works. So interesting, you lay our water against a particular style, and see this is still much higher. I think there's like 170 or 180 or something like that. The problem with us is there's nothing over on this side of the equation, so you got to add some gypsum or calcium in some way, depending upon what effect you're trying to get, whether you're trying to bring out the chloride or the sulfate, depending upon what kind of beer you're looking at. That's where it is. And so, but yeah, so you can match this to other beers, but the bottom line is that you can't. Well, you can't. We've all used this water without doing any adds. You can make much better beer if you just add a little bit to bring some of these numbers up and some of the other numbers down by diluting or adding some minerals. So, so that's the whole point of this. Good beer, or good water makes good beer, and we all want to make good beer because we want you to bring in good beer so we can drink it when we have hams meeting. So, any other questions? So, lactic acid, aside from adding the minerals to the water that help to reduce residual alkaline, if all your numbers here were about right, and you still needed to bring the the residual alkalinity down, you can add lactic acid in. You'll get the pH right, but you may not get all these other numbers right.
Well, I tried it.
Yeah, so all it's going to do is just get this part of the process right. It's going to bring your pH down to the right number. But all this other business about how the aroma and the flavor and all that stuff comes out is still going to be lacking because all these numbers aren't right here to begin with. So
it's a Band-Aid, but not a fix.
yeah, it's part of the fix. It's just not the whole thing because we've tried that too. So that's how I got to this point. So the question was about boiling the water. So the boiling part, because I tried that. I got a water kit and I thought, well, okay, if I boil it, then I'm going to boil off the chlorine, which chloride is an atom of that. What I got was more condensed chloride by doing that because I just reduced the amount of water that was there and the minerals stayed the same. They say if you put Camden tablets, let it sit overnight, then the chlorine will evaporate. But just boiling it down, I thought the same thing, tested it, and it only made some of these things, the salt and the chloride, worse by doing that ahead of time. So, because you boil off some of that. Other questions? Okay, thank you all very much. So I encourage you to come up. I've got I'll move the chart back. Just it's not necessarily part of the other tasting. Just come up and taste the beer. Just pour a little bit. There's the base sample on the left, and just kind of work your way across. I added a little bit to each one, and you'll be able to taste the difference of the same beer with just a little more calcium or magnesium or whatever in it. So anyway, all right, thanks y'all.